Dear students, in discrete mathematics, we have completed two units, that is unit 2 and unit 3. Unit 2 and 3, that is of graph theory units. Both the units are from graph theory. Okay, I have sent you the question bank for the entire paper. So I have suggested you to write answers to the question bank of unit 3. Both part A and part B you have to answer. For unit 3, you need to answer the questions in the question bank. Right? For unit 3, the latest unit, part A and part B. And you need to submit that as soon as the college reopens on 17th November. Fine. So we proceed further for the next unit, unit 4. Analysis of algorithms. Little computer based unit. Okay. What is an algorithm? An algorithm means it's a step-by-step specification. An algorithm is a step-by-step. Computer science students know the definition. PMC students know the definition. An algorithm is a step-by-step specification. Step-by-step specification of what? On how to perform a task. On how to perform a task, a given task. Right? What is an algorithm? Algorithm is a method. Algorithm or method. It is a step-by-step specification on how to perform a given task, given a problem. For example, you want to find the largest of n numbers. How do you find? You want to solve a quadratic equation, ax square plus bx plus c equal to 0. What are the steps involved in getting the roots of this equation? Right? And the steps involved in performing a given task, that is called an algorithm. Algorithm is that. Okay. An algorithm is a step-by-step specification on how to perform a given task. Okay. I'll make one more definition here. Time complexity. Time complexity of an algorithm. What do you mean by time complexity of an algorithm? Okay. In order to determine the cost of execution, execution means the processing the program. Execution. Take action here. You have to take action, you have to perform. To determine the cost of execution, of a given algorithm, the most important factor is that what is the time taken for execution of the algorithm? Right? The time taken for the execution of the algorithm, right? To take action, that is the execution here. The most important factor is the time taken for the execution of the algorithm. The time taken for the execution of an algorithm, it is referred to be the time complexity of the algorithm. Time complexity. I repeat, the time taken for the execution of an algorithm is referred to be is called the time complexity of an algorithm. Right? Of the algorithm. Time complexity of the algorithm. Okay. So we have made two definitions. What is an algorithm and what is the time? What do you mean by time complexity of an algorithm? Alright. How many algorithms we are going to study here in this unit? We are going to study three main algorithms here. One is largest one algorithm. Second one is largest two algorithm. Third one is bubble sort algorithm. So there are 3 algorithms. Today let us study, in this session we study largest one algorithm. Why this largest one algorithm meant for? Largest one algorithm is meant for, right, finding the largest of n numbers. For finding the largest of n numbers, x1, x2, etc., xn. Okay, this algorithm largest one is meant for finding the largest of n numbers. Okay, so what you need to do andre, first you have to state the algorithm. You have to state the algorithm and then give a formal proof for that. State the algorithm largest one and justify the algorithm with the formal proof. This is a 6-mark question. Okay, all the 3 algorithms are very, very important. We are going to ask in the university exam. So I'll pick largest one algorithm for discussion now. Okay, the statement is here. Look at the statement. Suppose we have n distinct numbers stored in n registers. You think of n boxes. N boxes labeled as x1, x2, xn. Assume that there are n boxes. Box 1, box 2, box 3, the last box. The first box labeled as x1. Second one labeled as x2, x3, x4, etc., xn. Okay, there are n boxes here. Fine. Initially, place the value of x1. See, whatever stored in x1, whatever value you store, see, you have to store n values here in n boxes. N values are stored in n boxes. What does the algorithm says? You store the value found in x1, in the box x1, in a register called max. It is another box. Say max is another box. Assume it is another box. Whatever value you find here in x1, in this box, in this register, we call it as register. Register. In the register x1, whatever value you have, you put it in the box max, in the register max. Okay. Initially, place the value of x1 in a register called max. ಒಂದು ಕೆಲಸ ಇದೆ, ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಇದು. ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ಅಂದರೆ I equal to 2 ಅಂದರೆ ಸೆಕೆಂಡ್ ವ್ಯಾಲ್ಯೂ, ಥರ್ಡ್ ವ್ಯಾಲ್ಯೂ, nth ವ್ಯಾಲ್ಯೂ. For I equal to 2, 3 up to n. Do the following. What you have to do? Compare the number in the register xi with the number in the register max. Compare the number in the register xi with the number in the register max. If the number in xi is larger than the number in the max, then move the number in the register xi to max. ಯಾವಾಗಿದು? If xi value stored in xi is larger than the value stored in max, then this value shifted here. Otherwise don't do anything. Otherwise do nothing. Okay? ಈ ರೀತಿ ಕಂಪ್ಯಾರಿಸನ್ ಮಾಡ್ತಾ ಬಂದಾಗ ಫೈನಲಿ the number in the register max is the largest of n numbers. Fine? I'll explain the algorithm again here. Suppose you have n registers x1, x2, etc., xn. Okay? The n values are placed here. N given values are placed here. You want to find the largest of n numbers. You take another register which we call as max. Store the value in x1 here. x1 ಅಲ್ಲಿ ಯಾವ ವ್ಯಾಲ್ಯೂ ಉಂಟು ಆ ವ್ಯಾಲ್ಯೂ ತಂದು ಇಲ್ಲಿ ಹಾಕಿ ಮ್ಯಾಕ್ಸ್ ಅಲ್ಲಿ. ನೆಕ್ಸ್ಟ್, ಫಾರ್ I is equal to 2 to n, I is equal to 2 to n, compare max with these each of the register. ಈ ಆರ್ಡರ್ಲಿ ಹೋಗೋದಾದರೆ ಕಂಪೇರ್ ದ ವ್ಯಾಲ್ಯೂ ಇನ್ ಮ್ಯಾಕ್ಸ್ with the value x2. If x2 is larger, value here is larger, shift this value, move this value to the register max. If x2 is smaller than the value here, do nothing, don't do anything. Okay? First x2 ಜೊತೆ ಕಂಪೇರ್ ಮಾಡಿ. x2 ಲಾರ್ಜರ್ ಆದರೆ x2 ಅಂತಂದು ಇಲ್ಲಿ ಹಾಕಿ. ಇಲ್ಲದಿದ್ದರೆ ಅಲ್ಲೇ ಬಿಡಿ, ಈ ವ್ಯಾಲ್ಯೂ ಇಲ್ಲಿ ಇರುತ್ತೆ x1. ಫೈನ್? ಓಕೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ 2, ರೈಟ್. 2 ಆದಮೇಲೆ 7, ಆಮೇಲೆ 3, ಓಕೆ, ಆಮೇಲೆ 4, ಹೀಗೆ ಉಂಟು ಇಟ್ಕೊಳ್ಳಿ. ಫಸ್ಟ್ ಏನು ಮಾಡ್ತೀರಾ, ಯು ಪ್ಲೇಸ್ 2 ಹಿಯರ್. ಕಂಪೇರ್ 2 ಆ್ಯಂಡ್ 7. 7 is larger. 7 ಅನ್ನು ಇಲ್ಲಿ ತಂದು ಹಾಕಿ, 2 ಅನ್ನು ಇಲ್ಲಿ ಹಾಕಿ, ರೈಟ್. ಶಿಫ್ಟ್ ದಿಸ್, ರಿಮೂವ್ ದಿಸ್, ಯು ಪುಟ್ 7 ಹಿಯರ್. Compare 7 and 3. 3 is smaller, 7 is larger. Don't do anything. Do nothing. No shifting required. Next, compare 7 and 4. x1, x2, x3, x4, x2, x3, x4, xn. 4 is smaller than 7. So do nothing. Suppose next value is 9. While comparing 9 and 7, 9 is larger than 7. So you shift 9 to this register max. ಇದನ್ನು ತಂದು ಇಲ್ಲಿ ಹಾಕಿ. ಅದೇ ರೀತಿ ಲಾಸ್ಟ್ ನಂಬರ್ ತನಕ ಬನ್ನಿ. ಕಮ್ ಅಪ್ ಟು xn. xn ಕಂಪೇರ್ ಮಾಡುವಾಗ xn ಲಾರ್ಜರ್ ಇದ್ದರೆ ಇದರಿಂದ ಶಿಫ್ಟ್ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಟು ದ ರಿಜಿಸ್ಟರ್ ಮ್ಯಾಕ್ಸ್. ಇದನ್ನು ಇಲ್ಲಿಗೆ ತನ್ನಿ. ಇಲ್ಲಾಂದರೆ ಡೋಂಟ್ ಡೂ ಎನಿಥಿಂಗ್. ಓಕೆ. ಸೊ ಆಫ್ಟರ್ ಆಲ್ ದ ಕಂಪ್ಯಾರಿಸನ್ಸ್ ಆರ್ ಓವರ್, ಫೈನಲಿ ಇನ್ ದ ರಿಜಿಸ್ಟರ್ ಮ್ಯಾಕ್ಸ್ the largest of n numbers will be stored. This is the algorithm known as largest one algorithm. Okay? Largest one algorithm is fine. So you are proving this by mathematical induction. You are proving the result by mathematical induction. What is the induction process? I repeat the proof. Mathematical induction alli ನೀವು prove ಮಾಡ್ತೀರಾ. Starting with the I is equal to 2. I equal to 2 ಅಂದರೆ you are taking two values, x1 and x2. You are comparing, you are having a register called max. You place max here, x1 here. Compare x1 with x2, the larger will be placed here. x1 ತಂದು x1 ಅಲ್ಲಿ ಯಾವ ವ್ಯಾಲ್ಯೂ ಉಂಟು ಅದನ್ನು ಇದರೊಳಗೆ ಇಡಿ. Compare this value with the x2. Whichever larger you put it in max. Okay. So for I equal to 200, when two values are compared, right, the number in the register max is the larger of these two, larger of x1 and x2. Fine. This is actually known as the basis for mathematical induction. Foundation step idu. Basis for induction is this, comparing first two values. ನೆಕ್ಸ್ಟ್ ಇಂಡಕ್ಟಿವ್ ಹೈಪೋಥಿಸಿಸ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಇಂಡಕ್ಟಿವ್ ಹೈಪೋಥಿಸಿಸ್ ಅಥವಾ ಇಂಡಕ್ಟಿವ್ ಸ್ಟೆಪ್ ಅಂತ ಹೇಳ್ಬೋದು. ವಾಟ್ ಈಸ್ ದಿಸ್? ಯು ಆರ್ ಎಸ್ಯೂಮಿಂಗ್ ದ ರಿಸಲ್ಟ್. ಎಸ್ಯೂಮ್ ದ್ಯಾಟ್ ಯುವರ್ algorithm is true for what? I is equal to k. What do you mean by saying that result is true for I equal to k? Among k registers, x1, x2, etc., xk, right? The largest of k registers, largest of values stored in the k registers will be put in the register max. Largest of k values will be placed here. Okay. So this is inductive hypothesis. What is the next step? Conclusion step. Next one is conclusion step. That is, you have to go for next larger value. Next larger value ಯಾವುದು? I is equal to k plus 1. Till I equal to k, you are assuming that result is true. That is, among k values, the largest is stored in the register max. For I equal to k plus 1, you have to execute the step 2. Step 2 ಅಂದರೆ comparing two values. Step 2 ಅಂದರೆ ಎಲ್ಲಿ ಉಂಟು ಮಾತ್ರ. Step 2 ಅಂದರೆ ಇದು. For I equal to 2, 3, 4, etc. n, compare the number in the register xi with the number in the register max. ಇದು step 2 ಅಂದರೆ ಇದು step 2. Comparing the value in the registers with the value in max. Okay, fine. ಈಗ ನೋಡಿ, I equal to k plus 1, you execute step 2. Execution of step 2 ಅಂದರೆ comparing the values. Okay, what you will get? You will find that the number in the register max is the largest among x1, x2, x3, xk, xk plus 1. Among k plus 1 registers, the value, right, stored in max is larger of x1, x2, etc. xk plus 1. ಇಷ್ಟೇ ಇರೋದು. ಇಂಡಕ್ಷನ್ ಅಂದರೆ ಅಷ್ಟೇ. You should have a basis for induction, inductive assumption, then proving for next larger value. That's all. Thus what happens? Thus the algorithm largest one. Thus the algorithm largest one, right, places in the register max, what it places? The larger of n numbers, right? The largest of n numbers. Compare ಮಾಡ್ತಾ ಹೋದ್ರೆ ಇದಷ್ಟೇ, right? You take a box, call it as max, x1 value ಇಲ್ಲಿ ತಂದು ಹಾಕಿ, compare this value with x2, x3, x4, xk. If any of these values are larger than value here, shift this to here. ಇದನ್ನು ತಂದು ಇಲ್ಲಿ ಹಾಕಿ. x2 larger than value here ಇದ್ದರೆ x2 ತಂದು ಇಲ್ಲಿ ಹಾಕಿ. Compare this value with the next value, x3. If x3 is smaller, don't do anything. If x3 is larger, you place x3 here. Likewise, move up to xk. The larger of all these values will be placed in the register max. This is the algorithm largest one. What is the time complexity? Time complexity of this algorithm. Time complexity of the algorithm ಏನು ಅಂತ ಕ್ವಶನ್ ಇತ್ತು. Time complexity of the algorithm. Fine. What is the time complexity of the algorithm? ಇಲ್ಲಿ ಎಷ್ಟು ಕಂಪ್ಯಾರಿಸನ್ ಆಯಿತು ಹೇಳಿ ನನಗೆ. See, you are having n values, x1, x2, etc. xn, n values. ಇದರಲ್ಲಿ ಒಂದು ವ್ಯಾಲ್ಯೂನ ತೆಗೆದು ನೀವು ಮ್ಯಾಕ್ಸಲ್ಲಿ ಹಾಕ್ತೀರಾ. ಯು ಆರ್ ಪುಟಿಂಗ್ ಒನ್ ಆಫ್ ದ ವ್ಯಾಲ್ಯೂ ಇನ್ ಮ್ಯಾಕ್ಸ್. ಇದನ್ನು ತಂದು ಇಲ್ಲಿ ಹಾಕಿದ್ದು. ಹೌ ಮೆನಿ ವ್ಯಾಲ್ಯೂಸ್ ಲೆಫ್ಟ್ ಔಟ್ ಹಿಯರ್? ದೇರ್ ಆರ್ n minus 1 ವ್ಯಾಲ್ಯೂಸ್. ಟೋಟಲಿ n ವ್ಯಾಲ್ಯೂಸ್ ಇತ್ತು, ಒಂದು ವ್ಯಾಲ್ಯೂ ತಂದು ಇಲ್ಲಿ ಹಾಕಿದ್ರಿ ಇದರೊಳಗೆ. ಸೊ ಇಲ್ಲಿ n minus 1 ವ್ಯಾಲ್ಯೂಸ್ ಉಂಟು. ಯು ಹ್ಯಾವ್ ಟು ಕಂಪೇರ್ ದ ವ್ಯಾಲ್ಯೂ ಇನ್ ಮ್ಯಾಕ್ಸ್ with each of these x2, x3, x4, xn. ಈ ಪ್ರತಿಯೊಂದು ವ್ಯಾಲ್ಯೂ ನೀವು ಕಂಪೇರ್ ಮಾಡಬೇಕು. ಹೌ ಮೆನಿ ಕಂಪ್ಯಾರಿಷನ್? n minus 1 ಕಂಪ್ಯಾರಿಷನ್. There are total n minus 1 tasks you are having, n minus 1 comparisons you are having. Assume that c is the time taken for one comparison. One comparison ಗೆ time is to c. ಹಾಗೆ n minus 1 ಕಂಪ್ಯಾರಿಷನ್ಸ್ಗೆ ವಾಟ್ ಇಸ್ ದ ಟೈಮ್? c into n minus 1. The time taken t for n minus 1 comparison is c into n minus 1, where c is the time taken for one comparison. If t equal to c into n minus 1, that is t is proportional to n minus 1. The time complexity of the algorithm largest one is this. The time taken for execution of the algorithm, it is proportional to the number of comparisons. Comparison ಎಷ್ಟು ಉಂಟು ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿ ಉಂಟು ಟೈಮ್. If the comparison is less, the time taken will be less. If comparison is more, time taken will be more. So time taken for the execution of the algorithm is proportional to n minus 1. n minus 1 ಅಂದರೆ the total number of comparisons you are making to get the largest of n values. ಇದು ಟೈಮ್ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ. ಎಕ್ಸಾಮಲ್ಲಿ ಡಿಸ್ಕಸ್ ದ ಟೈಮ್ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ ಅಂತ ಕ್ವಶನ್ ಕೊಡ್ತೇವೆ 3 ಮಾರ್ಕ್ ಕ್ವಶನ್ಗೆ. ಆಗ ನೀವು ಇಷ್ಟನ್ನೇ ಬರೆದ್ರೆ ಸಾಕು. Time, there are n minus 1 comparison. If c is the time taken for one comparison, what is the total time taken? c into n minus 1. So total time taken is proportional to n minus 1. ಇದು ಟೈಮ್ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ. So largest one algorithm complete ಆಯಿತು. Next algorithm is largest 2. This we will discuss in the next session. Largest 2. So we have just begun the unit 4 of our optional paper, discrete mathematics. Analysis of algorithm is there. Finite state machines you have to study. Languages and the sudden topic languages and the okay. ಆಮೇಲೆ ಫೈನೈಟ್ ಸ್ಟೇಟ್ ಮೆಷಿನ್ ಆಸ್ ಲ್ಯಾಂಗ್ವೇಜ್ ರೆಕಗ್ನೈಸರ್ ಅಂತ ಒಂದು ಟಾಪಿಕ್ ಇದೆ, ರೈಟ್. ಈ ಥರ ಸಣ್ಣ ಸಣ್ಣ ಟಾಪಿಕ್ಸ್ ಇದೆ. ನಾಟ್ ಎ ವೆರಿ ಬಿಗ್ ಯೂನಿಟ್, ಇಟ್ ಇಸ್ ಸ್ಮಾಲ್ ಯೂನಿಟ್, ಬಟ್ ಟಾಪಿಕ್ಸ್ ಆರ್ ಲಿಟಲ್ ನ್ಯೂ ಫಾರ್ ಯು. ಲೆಟ್ಸ್ ಸಿ how we are going to appreciate this unit. As we complete the unit, you will come to know. Till then, we'll proceed. Today, we have completed one algorithm. That is largest one algorithm. I'm going to send the notes and video both. So, please study this, go through the video, study the notes, write the notes in your notebook. Okay, thank you.